Just tell me what you can see on the screen. Hello, are you there? Okay, PPT for inverse Laplace transform. Okay, so let's start. I hope all of you already watched the PPTs, the videos that were there for Laplace transform, the basic rule of Laplace transform, first shifting property, and multiplication by t. Any question in that regard? Okay, let me just show you what we did before. We studied these things in previous class. Basic of Laplace transform, okay, by using the rule sheet. Then we studied the linearity property of Laplace transform by using this rule of Laplace transform, where we solve the equation in this way. We are having the Laplace transform of sum or difference of more than one function, and then we find it the Laplace transform of each term individually and answered it. Okay. Then we studied first shifting property, that is multiplication by e power t. Then we answered these questions. Okay. Any doubt in this regard? Abdul Rahman, you didn't go on through any of the slides or videos? Oh, you missed it, and you didn't attend the class last week, I guess. Okay, now what we can do is, like I already explained first shifting property, you didn't gone through. Okay, so let me just give you a briefly about the first shifting property. But I think you can understand it very well from there. Okay, let me just give you one example for that. I already uploaded videos for that. Okay, so you can just go on through that in detail in case you didn't understand it. So I'll just explain you briefly what the first shifting property is. So first shifting property, what it states that, just give me a moment. Let me just clear this slide and come back to it. S plus A. So this gives you f of s plus a. So let's take this example. It's product of two terms, and one of the function is e power minus at. So we compare it with the given term. So when we compare, in place of e power minus at, we have e power minus 90. In place of f of t, we have cos of minus 70. After we get these two things, we have to get f of s and the value of s which will replace. So e power 9st gives you s goes to s. Now it is minus, it becomes plus 9. This gives you fs. So what is the fs for this? Cos of minus 70 gives you s over s square plus minus 7 power 2. Which is basically this. Now put it in the formula, this formula. So this will give you this. This is the formula. We substitute the value of f of s as this, and s goes to s plus a by s plus 9. Then we replaced s at both the places by s plus 9. Okay, so this is how we work. So there are some examples based on it, like how to work on this. It is e power minus 2t cos h 3t. So here s goes to s plus 2, fs is s over s square minus 3 square. Then substitute it in this formula. Similarly, if you have for other functions, you work in this way. So these are the examples that we answered, and the other thing that we answered is you have to apply the shifting property in two different terms, two times. Here it is e power minus 90 and here e power 2t. So you are using the property twice. Okay, so you will understand these things through the videos. Okay, Fatma, shall we move? I'm sure it will be clear when you watch the videos. This is the only idea. Okay. So in today's class, we are going to begin with the inverse Laplace transform. Okay. So in inverse Laplace transform, first of all we define the inverse Laplace transform. So it is the inverse of Laplace transform. So like you have derivative and integration as reverse process of each other. In the same way we have Laplace transform and inverse Laplace transform as the reverse operator for each other. If we denote the Laplace transform of any function of t as a function of s, then the inverse Laplace transform is defined as L inverse. We are using the notation L to the power minus 1. So we use L power minus 1 inverse. So see, this L will go to the other side. So inverse Laplace operator is applied on a function of s, which gives you a function of t. Okay, so this is what we were doing. Whenever we have function of t, we apply Laplace transform on it and we get a function of s. On the other hand, if we have a function of s and we want to return back to original function, we apply inverse Laplace transform and get the function of t. Okay, so let's see how it works. Now this is the table that we use for Laplace transform. When we were working for Laplace transform, we are looking for the functions in the first column and the corresponding answer in the second column. So we were moving from left to right. Now when we want to solve it for inverse Laplace transform, we make use of the same table and move from right to left. Means we will look for the function here and the corresponding answer here. What does it mean? The first rule, it will be Laplace inverse of c over s. Any constant over s is the constant. The second rule will give you Laplace inverse of 1 over s plus any constant. It is e power minus at and so on. Okay, so let's solve. Suppose you need to find Laplace inverse of 6 divide s. Now 6 is a constant, so we can make use of rule number 1. So 6 over s, what it will give you? 6. Okay, now next 1 over s plus 9. S plus 9. So it is matching with this rule. So we are going to make use of this rule. It gives you e power minus 9t. Third one. Laplace inverse of 6 over s square plus 36. Now here check the denominator. S square plus something. So s square plus something. 36 we can write easily as 6 square. Now we have these two rules. To know that out of sine and cosine, which rule we have to use? We have to check the numerator. Here in the numerator we have s, whereas here we have a number. Okay, so check your question. You have a number or a function of s. So here we have a number. So whenever we have a number, it means we have to work with the sine rule. And what is the requirement? If it is a square here, you should have a here, the square root of it. So if it is 6 square, you need 6. So what it will give you? Sine 6t directly. Similarly, Laplace inverse of 5 factorial over s to the power 6. So here power goes beyond 2. Whenever in any question power is going more than 2, you don't have any other option other than t power n. This only allows the more power of s. So to use this rule, if it is n plus 1, you should have n here. So here 6 is your n plus 1. So what will be the value of n? 5. So what you need in the numerator? 5 factorial, which is present. So this gives you t power 5. Is it clear? Okay, good. You are giving answers. I am recording also, but if you can speak, it will be better because I am not checking. I am not able to check simultaneously the chat, and I am writing. So it's okay if you can speak if you are answering. Okay. But what I will do after explanation of each slide, I will come back to chat and check it. So let's work out with the different questions now. So this is the rule sheet that will be given to you. We have say rule 1, 2, 3, 4, 5, 6, 7 and 8. So let's see how to work on it. Remember, in inverse Laplace transform, we have to start from right to left. Okay, we are looking for the functions in the second column. So let's take another example. Say Laplace inverse of I will say s over a square minus 36. So the first thing that you have to do is check which rule is matching. So s over s square minus 36. For minus you have these two rules. Okay. Now in these two rules, in one of the rule you have s, in another rule you have a. Check your question, you have s. So it means you are going to work with this rule. So 36, it is 6 to the power 2. So you will get cos h 6t. Clear? Good. Okay. Now, if you have say Laplace inverse of, see in the same example I have 7s over s square minus 36. Can you tell me what will be the answer in this case? Yes, write your answer. I'm watching. Just think how you will work with it. 7 cos h 60, correct. Because see, you have a number 7, which is a constant, which is not required when you are using this rule. So you take 7 outside the transform, 7 outside, and on the remaining function, s over s square minus 36, you apply the rule like we did here. Okay, and that will give you okay, so here for the remaining portion you apply the rule as previous. So this gives you cos h 60. So we keep the things that is required and take out the unnecessary things. Okay, so similarly if I have say Laplace inverse of let's work with, assume 2 over s square plus say 9. Tell me how you will work with it. Just think what it can be. First of all, you have to check which rule is working for this. 2 over s square plus 9. So out of 8 rules, which rule is working? Rule number 4, correct. Okay, sin 80, fine. Then, what is the requirement of that rule? This is correct, that you are going to work with this rule. Now this rule required that if it is a square, you should have a. So in place of a square, you have 9, which is 3 square. But you have 2. And you don't want 2. Instead, you want 3. So as you don't want 2, take it outside. Then you left with Laplace inverse of 1 over a square plus 3 square. Any idea what shall we do next? A should be same. Multiply with 3. Yes, correct. That's it. See, now we have this 1 over a square plus 3 square. But to use this rule, we need a, which is missing. So we need here 3. So we multiply by 3. Now, if I multiply by 3, it becomes 2 times 3, 6. And in the question, I have only 2. It means it's changing my question. So we cannot do that. So to make it same, if we are multiplying by a number, we divide by the same number. So that when we simplify 2 times 3, 6, divide 3, 2. We will get the same term. So our question remain unchanged and we reduce it in the form for which we have the rule. So now we can write it as 2 by 3 and for this term we can write sine of 3t. So our target is to convert it into a form so that rule is applicable. Clear? Okay. So let's move to the next question. Say, if I have say Laplace inverse of, assume 3s over a square plus say 16. Tell me what will be the answer. It is similar to question number 6, but we are using different rule. Again we have 3 that we don't need. So 3 is outside. What will be the inverse Laplace of the remaining term? Correct, cos of 4t. 3 cos of 4t. Okay, now let's take Laplace inverse of 3 over s minus 2. Which rule we are going to use? Rule number 3, correct. And then in rule number 3, we need here 1. Right? But what we have 3. We don't need it. So again, we take this 3 outside. So we don't need this 3. We move it outside. So this gives you 3 times Laplace inverse of 1 over s minus 2. So this is equal to 3 times, now 1 over s minus 2. If it is s plus a, it gives you e power minus a. We change the sign. So here it will be e power 2t, correct. E power 2t. Number will be same. It was minus, we made it plus. Okay. Now, let's see. Now let's work with some questions based on this rule. What actually this rule says? This rule says that Laplace inverse of n factorial over s to the power n plus 1 is t power n, right? So can I write it as Laplace inverse of, means there is another way of writing it, n plus 1 as t power n over n factorial. Because n factorial is constant, we can take it outside the operator. So how do we work with it? Say question number 10. Laplace inverse of, assume you have, say 2 divide s to the power 20. Okay, so let's see how to work on this example. Now s power 20, the power is going more than 2. So you have to make use of this rule only. So what this rule says, if you have n plus 1 in the denominator, you should have n factorial. 1 less than that in the numerator. So what you have? You have 20 here. So n plus 1 is 20. So what will be the value of n? 20 minus 1. So n is 19. Okay. So you need 19 factorial here. But you have 2, which is not required. So what you will do with 2? You take it outside and write it as Laplace inverse of 1 over s to the power 20. Right? Now, as per the requirement, you need here 19 factorial, which is not available. So we multiply by it, and to make the question unchanged, we divide also by it. So that what will happen for this? You have the formula t over 19. So the result will become 2 over 19 factorial t to the power 19. Okay. If you think that this is very long and you do not understand it, you can use this formula directly and work with it. See how it will be another way. Say you have Laplace inverse of 2 over s power 20. Now 2 is a number which is not required. Laplace inverse of 1 over s power 20. Now as per the rule, if it is n plus 1, you need n factorial. So it is 20, means s power n plus 1. If it is n plus 1, it gives you t power n. Okay, a number less than that. So if it is 20, it gives you t power 9. So you will get 2 into t power 9, and you need 19 factorial there, which is not available. So divide by 19 factorial. So see, you are getting the same answers if you work on this way. So you can use any way, you will end up with the same answer. Is this clear? Because if it is clear, then only I will move to the next question. Yeah, I mean t to the power 19. Yes. Sorry, I mentioned 9. It should be 19. Sorry. Now I corrected it. Okay, just to test if it is clear to you or not. Tell me the answer for this one. Laplace inverse of 7 divide s to the power 6. Tell me what will be the answer. Type your answer. Check your answer again, Fatma. Fatma, check again. What about Abdul Rahman? Okay. Check your answer again. How you got e power 5? And Fatma, how you got answer in S? It should be in T. Okay. What about Omar? Why he is so silent? Are you with us? Okay, you corrected Abdul Rahman 5 factorial. But what is the power? E power 5 or T power 5? Yes, T power 5. And what about you, Fatma? S power 5 or T power 5? T power 5, correct. And Omar, what happened to you? You're not with us? So, S power 6. So, n plus 1 is 6, gives you n is equal to 5, right? Now, so we don't need this 7, take it outside. S power 6 gives you T power 5 over. Now we need 5 factorial, which is not there, so over 5 factorial directly. Remember, whenever you are doing inverse Laplace transform here, you should not have any S. It should contain only T terms. Otherwise, it's wrong. Okay? So just remember these things. So similarly, if you have, say, what you will do in this case, if I have same question, I have like this. What will be the answer? How my answer will change in this case? Just try. It's just basic mathematics that you have to use along with what you studied today. Confused? See, okay, let me explain. So what is the thing? You have s in the numerator and here s power 6. So whenever you have s in top, you have either this rule or this rule, where you need s square plus something or s square minus something in the denominator. So it means we cannot make use of these two rules. Now still, we need to find the solution. So we try to simplify this first. So it gives you Laplace inverse of 7 over. Now s means s power 1. Can I cancel s power 1 with s power 6? So we left with s power 5. Now it converted into the form so that I can make use of this rule. So here n plus 1 is 5, which gives you n as 4. Again, 7 is not useful. S power 5 means t power 4 over 4 factorial. So this is how we work here. Okay? Yeah, correct. Correct, Shada. Good. So the only thing is you have to convert the rule in a form so that rule is applicable for it. Rule is available for it. So same thing can we can do the same thing with the other rules as well. Like suppose what was the example number 12 here, 13th. Say Say if you have Laplace inverse of 25 over a square minus 81. Okay, so a square minus something and above you have a number, so clear that you are going to use this rule. So 81 means 9 power 2. As per the rule you need 9 here, so 25 is not required, taken outside. For the remaining term you will left with Laplace inverse of 1 over a square minus 9 square. Now to apply that rule, what you need? You need here 9. Multiply by 9, divide by 9. So this gives you 25 over 9 sine h 90. Okay, now tell me how you will answer this. Suppose you have s square plus 11. What do you think the answer will be for question number 14? Try. You are trying? Cos square root of 11t. Correct. So this is the thing. It's not necessary that you always get a perfect square. Like in all the examples, it was 81, you got 9 square. Here in this example it was 36, so which is 6 square. 9 which was 3 square. 16 which was 4 square. So but it's not necessary that you always get the perfect square. The idea is you should have the square root of the number in the numerator. So in this case, as you don't have like 11, you can write it as square root of 11 and power 2. So this will give you cos of square root of 11t. It's not necessary to be a perfect square. Okay, so same thing can be done with the example of sine. Say if I have 3 over a square plus 11. So again 11 means square root of 11 power 2. So 3, I don't need 3, that's why. And then sine of root 11t, and we don't have root 11, so we should have square root of 11. I hope it's clear how it came. See how we worked with it. 3 Laplace inverse of 1 over a square plus square root of 11 power 2. Okay. Now when it is root 11 power 2, we need root 11 in the numerator. So we multiply by root 11 and we divide by root 11. So this gives you sine of 11t, and this term as it is. I hope it's clear. If clear, tell me, then I will move to the next example. Okay, so let's work with the last rule. If it is say Laplace inverse of direct application, e power minus 3s. Remember the function of s, don't mix with this one. So it gives you delta t minus 3. And then if I have, say, Laplace inverse of 2e power 7s. So 2 I don't need, delta t. If it is minus a, I am getting here minus. So if it is positive, you will get positive of a. So delta of t plus 7. Remember that here no s. Here no s in the final answer. No s in the final answer. Okay. Now next, we have rules for partial fraction. We will work on these things when we come across this kind of term. Say if you have to find Laplace inverse of, say, 1 over s plus 1 s plus 2. So now it is in multiplication. You cannot use this rule twice. Like you cannot work on it like if you plan like Laplace inverse of 1 over s plus 1 multiply Laplace inverse of 1 over s plus 2 and then find for this as e power minus t, e power minus 2t as the answer. No, you cannot work in this way. This is not possible in inverse Laplace transform. Not possible, not allowed. So for that, what we have to do, we have to write this multiplication s plus 1 s plus 2. So here it can be anything. We try to write it in the form that it is s plus 1 plus or minus some number. Here it can be any number over s plus 2. So when we have separates, we are able to split these two terms in the form of plus or minus. Then okay, we can say that this number, say this number is capital X, this number is capital Y. So x times e power minus t, y times e power minus 2t, and in between the sign plus or minus. This is possible. Okay, in terms of whenever we have plus or minus. But whenever we have multiplication, it is not possible. So for that, what you have to do is, we have to write it in this way. We have to follow the rules of partial fraction. So what is the requirement of this rule? You need to memorize these things. Okay. So what it says, when under which conditions you can use the rules of partial fraction. The numerator must be lower degree than the denominator. Means if the degree of, it should be in terms of s. Say if it is s over s square plus something. S into s plus 1. Here it should be s plus 1, s square plus 1, s minus 2. Something like that. Here the degree, the maximum power of s is 2. Here the maximum power of s is 3. So it should be in this way. Then second thing, factorize the denominator into its prime factors. Means if you have, say, 1 over s square minus 3s plus 2. So before applying the rules of partial fraction, you should write it as s minus 1, s minus 2. Factorize it and then apply the rule. So once these two conditions are fulfilled, let's see how to write it as a partial fraction. A linear factor s plus a means a factor of the type s plus 1, s plus 2, or it can be s minus 2, s minus 3 plus or minus, will give you a partial fraction of a over s plus 1 a. Okay. Like for instance, if you have, say, 1 over s plus 1 s minus 1. So when you write the partial fraction, you will be writing like a over, because this is a linear factor, you will write a over s plus 1 plus, now this is again a linear factor, b over s minus 1. Similarly, if you have three linear factors, say 2s over s plus 1, s plus 2, s minus 3. So you have 3 linear factors. So you will have one term for each. A over s plus 1, b over s plus 2 plus c over s minus 3. By default we write plus plus in between, and where a, b, c are constants, and we will see later how to find the values of those constants. So this is related to the property 1. Is this clear? Then I move to the next one. Okay. Now, second rule says that a repeated factor s plus a power 2 gives you two terms. A over s plus a with power 1, b over s plus a with power 2. Means you start with power 1 and reach to power 2, the maximum power for which the term is given. Similarly, if you have power 3, again you start with 1, power 1. You should have 3 terms, starting with power 1, then 2 and 3. For example, if I have say 2s plus 3, s over s minus 1 square. So for s, it's similar to the linear factor. I will write a over s plus. For s minus 1, repeated term with power 2. So you should get 2 terms. So write b over s minus 1 plus c over s minus 1 power 2. Okay. Plus is a constant. Yes. Plus is constant. We are always using plus, but later on when we do the calculation, it is possible that the values of a, b and c can be negative. Yes, by default it is plus. Okay. Now, next rule says that if you are getting a quadratic factor, when it is not possible to rationalize like this, to make factors like that, like suppose if you get s square plus 2, you cannot factorize it into product of two terms. So in this case, you will be writing two constants in the numerator with s as with one of the factor. So what I mean is, if you have say any number 3 s plus 1, and in denominator you have s square plus 3. So you cannot factorize this s square plus 3. So you will write for s plus 1, it's linear. So a over s plus 1, and when it is s square plus 3, you should have two different constants b and c, and with one of the constant it is important to write s, because if you write only b plus c, you can add them together and name another constant. Okay, so to avoid this thing, as we need, because of power 2 we need two constants, we use b and c and we multiply one of the constant with s. Okay, the next rule is the extension of this. When this quadratic factor repeated twice, you have to work in this way. There will be two different terms similar to this one. Okay, so at present you focus until 6. So tell me, what will be the partial fraction of s minus 19 over s plus 2 s minus 5? You are writing. How many terms we are going to have? A, B, C, D, or just A? Two, yes, correct. What about others? What do you think? How many terms? A over S plus S plus 2, S minus 5. All agree? Because we have two linear factor, S plus 2, S minus 5. So, A over S plus 2 plus B over S minus 5. What we did? We used this rule. This one. Third term. Okay. What about this one? 2 over S plus S into S plus 1. Is it correct? Since we have two terms, S and S plus 1, we have S plus 1, so we get two terms. Now we have three terms, S plus 1, S minus 1. We got three different terms with constants A, B and C. See, this is the first step. Now still we need to find the values of A and B. Okay, A, B, C, whatever terms are appearing, that I will tell you how. So similarly, S plus 7, just one term, S minus 2 power 2. So we have S minus 2 power 1, the first power, and second power. Okay. Now what you can see is, it doesn't matter what term you are having in numerator, 2 or 2s plus 1 or 3s minus 21. It's not changing the right side. It's same. Okay. So I will tell you that where we are going to, where this term, the numerator is going to affect when we solve it. So for this one, now it is a square plus 1. You cannot factorize it. So it will be in this way, bs plus c. One term with s. And then here. Now, how do we do this? First is we need to factorize it. So we factorize it as s minus 1, s minus 2, and then a over s minus 1, b over s minus 2. And sixth one like this, s square plus 2s. So you can see s in both the terms. Again factorize it. You can write it as s into s plus 2, and then you can cancel this s with s. So you don't have to do a plus b. So see, some questions can be tricky like this. It's okay, you can even write, if you work with this, you can write a over s plus b over s plus 2 and start working. But why to go for that when you can simply cancel it? On the other hand, if you are getting the term like 3 over s square plus 3s, then you can write it as 3 over s plus 3. Now here it is not possible to simplify. So in this case you don't have choice. You have to write a over s over b plus s plus 3 and then work on it. But here it is possible to simplify, so cancel it. It will reduce your time. So just before moving to the next step in any question anywhere, just try to simplify it. Is it clear? Okay, then let's move to the next thing, how to start solving these questions. Means what will be the next answer, next step, how to find the values of A, B. Okay, so for that, the procedure, let's start with this example. S square minus 5s plus 1 over s square minus s minus 12. So first thing is to factorize s square minus s minus 12. Okay, memorize this term, means see this thing properly, because this is going to be useful in many places. Okay, if you learned it properly now, it will be beneficial for you, because we are going to use the same thing for the next topic, which is Z transform. The procedure is almost same, just with a slight modification. So if you are learning it better now, you will learn it for two different topics. So we factorize it first into two brackets. Okay, so first we check the degree of numerator is lower than degree of denominator. Yes, here the maximum power of s is 1, here it is 2, so it is there. Then we make the factors. So we are looking, I hope you know how to make the factors. We are looking for two numbers which on multiplication gives you minus 12, and when you add them you will get minus 1. So these are minus 4 into 3. So it minus 4 plus 3 gives you minus 1. So the factors are s minus 4, s plus 3. Nowadays you have even calculator to work on this. Okay, good. I already got the answer there. Good. Next is, now it is in product. We cannot do it directly, so we have to use the method of partial fraction. So we write partial fraction as a over s minus 4, b over s plus 3. So we are writing 5s plus 1 as this as a over s minus 4 plus b over s minus 3. Now next thing is to simplify them. It is matching with how you add two rational numbers. Do you remember when you have rational numbers like 2 over 3, 5 over 7, how you will simplify them? You take the LCM, which is 3 times 7, and then you cross multiply. 2 times 7, 5 times 3. So same thing you will apply here. You will simplify. Denominator will be product of these two terms, s minus 4, s plus 3. Now you need to check what comes with A, what comes with B. Okay, so in this case it's okay, you can just cross multiply and work. But otherwise, if you check below A, you have s minus 4. So out of these two, s minus 4 already there. So what you left with? S plus 3. So you get s plus 3 here. Again, below B you have s plus 3. So out of these two terms, s plus 3 already there. So you left with s minus 4. Clear so far? Okay. Now, what you have to do when you look at this term and this term, what you can see, denominators are same. So we say that 5s plus 1 over s minus 4 s plus 3 is same as a times s plus 3 plus b times s minus 4 divided by s minus 4 s plus 3. So when denominators are same, the numerators like 5s plus 1 should equal to the numerator. Okay, so we compare them. So this will give us this thing. 5s plus 1 is equal to a times s plus 3 plus b times s minus 4. Okay, now here comes the thing of finding the value of a and b. Now there are many ways of finding the values of a and b, but I will go for the one which I feel easier compared to other values. So there is one way is you can collect the coefficient of s and compare, and the constant term, compare it. You come up with two equations of the form, say a plus b equal to 5, 3a minus 4b is equal to 1, and then solve it for values of a and b. But I don't want to go for this one because it will consume more time. Okay, so we will go for another easy method where we will see substituting different values of s. Okay, so we substitute. Now we need to find how many constant? Two constants. So we need, I will write in this place. So we need two constants. So we substitute two different values of s in this equation to get the answer. Now these values of s also we select in such a way that our calculation is easy. Okay, so I will select, say s is equal to 4. So what will happen if I use s is equal to 4 here? So remember that I have to change s at all the places. So what I will get when I replace s by 4, 5 times 4 plus 1 equal a times 4 plus 3 b times 4 minus 4. So 5 times 4 20, 20 plus 1 21 equal to 4 plus 3 7. I can write 7a. 4 minus 4 becomes 0. So this total term becomes 0. So this gives me directly the value of a as, say 21. I'll divide both sides by 7. So this gives me a is equal to 3. I got the value of a as 3. Clear? I hope up to here it's okay with you. Okay. Now next value I select for s as minus 3. So when I substitute s is equal to minus 3 in this equation, what I will get? Don't forget, you have to replace it on both sides, left side as well as right side. 5 times minus 3 plus 1 equal to a times minus 3 plus 3 plus b times minus 3 minus 4. So 5 times 3 gives you minus 15 plus 1, which is equal to minus 3 plus 3. This total term becomes 0, and this gives you minus 7b. So minus 14 equal minus 7b. This gives me b as 14 divided 7, which is 2. So see, I got directly the value of a and b by selecting s is equal to 4 and minus 3. So how do you know that you have to select s as 4 or minus 3? Means, how do I know? Again, there is a trick behind it. Anyone can guess that from where we are doing this? Means, how do I know that it's 4 and minus 3, which directly gives me the value of a and b? Check, the answer is there in the solution itself. Number besides a and b. Okay, that may be. You are closer, but that is not always true. What about others? See, you always get it from the denominator, from your question. You have factor s minus 4 and s plus 3. So you got s plus 4 by putting the factor s minus 4 equal to 0. This gives you S is equal to 4. Okay, so from the question. Similarly, if you put the second factor s plus 3, if you put s plus 3 equal to 0, this gives you the value s is equal to minus 3. So we always work with this. Inverse of the numbers beside s, and one of them should be 0. Yeah, it can be in that way, but the easiest way, yeah, Fatma, you got it. So how do you get the idea? Generally it comes from the denominator of the questions. Okay, so now what next? We get the value of a, we got the value of b. Now we have to substitute these values of a and b at the very first place where we introduced a and b, here and here, not at this place, neither at this place. So once we do the calculation, we get this one, 3 over s minus 4, 2 over s minus 3, because the value of a is 3 and b is 2. Now it is in the form of sum. So can we answer? Yes. Find the Laplace inverse of 3 over s minus 4 separately, 2 over s plus 3 separately, and then add the answer. Okay, I hope it's clear. Any doubt? Okay, so clear. Good. So let's work on this. Nine s minus 8 s square minus 2s. Let me write the question here. 9s minus 8 over, question was s square minus 2s. Tell me, how do I start with? First step. Correct, Shada. Good. Okay, so we can write it as 9s minus 8. First step is to factorize s over s minus 2. Is it possible to cancel something? No. Two terms in multiplication, so we cannot apply the rule directly. So we need to move to partial fraction. So we write it as a over s, b over s minus 2. Then we simplify. Okay, let me just write it here. So what it will give you? Denominator s minus 2. Actually we are working with this. So 9s minus 8 s minus 2. Just to check, it should be here, the term should be always same like you have in the question. Okay, so we are looking for a term to be multiplied with a and b. What will be the term that should multiply with a and b? So you can see that in the denominator of a you have s already there. So you left with s minus 2. That comes here. Below b you already have s minus 2. So you left with s. So now comparing the numerator, you get 9s minus 8 equal a times s minus 2 plus b times s. Okay, good, correct. Now we have to look for two different values of a and b, two different values of s to get the values of a and b. So again we work on the same idea. We have s and s minus 2. So we substitute s is equal to 0 and we substitute s minus 2 equal to 0. This gives you s is equal to 2. So we are going to use these two values in this equation. Okay, so you have to change s on the both side, here, here as well as here. So when you work with it, what you will get? 9 times 0 minus 8 is equal to 8 times 0 minus 2 plus b times 0. 9 times 0 becomes 0. So you left here with minus 8, which is equal to 0 minus 2 gives minus of 2. So minus 2a, b times 0 becomes 0. So this gives you the value of a as minus 8 divide minus 2, that is 4. Okay, when you replace s by 2, you get 9 times 2 minus 8, which is equal to 8 times 2 minus 2 plus b times 2. 9 times 2, 18 minus 8 equal 2 minus 2, 0. This term cancel. You left with 2b. 18 minus 8 is 10. Gives you 2 times b. So b is 10 over 2, which is 5. So we got the values of a and b. We substitute at the very first place where we introduced a and b. So now we got 9s minus 8 over s minus 2 as a, which is 4 divide s, plus b, which is 5 divide s minus 2. See, just one thing, be careful how do you write 5 and s. Sometimes when we write in hurry, 5 and s looks similar. So don't get confused, huh? Okay, got the answers as well. Good. So now apply Laplace inverse on both sides. So what we did by partial fraction, it was in multiplication, we changed it to addition. So Laplace inverse of 9s minus 8 over s minus 2 is same as Laplace inverse of 4 over s plus Laplace inverse of 5 over s minus 2. Now 4 over s is a constant, gives you 4. For this it gives you 5. 1 over s minus 2 gives you e power 2t. So the final answer will be 4. The sign in between is plus 5 e power 2t. This completes the answer. Okay, so it is possible that sometimes you get here minus after calculating the value of a and b. So it will not make a difference. I hope it's clear now. Good. What about Fatma Shada? It's clear? Okay, good. We have here Hilal and Omar as well. They are not responding. Are you there with us? Hilal, Omar? Okay. Okay. Good. I hope you are following, right? So this is what I wanted to explain in today's class. I think it's enough if I will stop for today here, because next is another example. of this type. S minus S, here you have S plus 2 and S minus 3 power 2. So I am planning to keep it for the next class. But what I observe in the next class of Thursday, most of you are not attending because it's 8 o'clock. Do you want the class at some other time? Please let me know. I can schedule it at other time as well. Any time on Tuesday is okay for me except 3 to 4 because I don't want you to lose your time. Okay, so okay, not a problem. I'll just give you the idea how you work with this. Here everything is same except one thing. You start with this a over s plus 2, b over s minus 3, c over s minus 3 power 2. So here this is how you get the term. This is what I wanted to explain. I'll just explain this and then we are done. So we say that this is equal to, first of all, denominator will be same as in the question. The question is s square minus 15s plus 41 over s plus 2 s minus 3 power 2. Don't multiply all these things and write here the denominator will be s plus 2 s minus 3 power 3, because if you write power 3 in the question you have power 2, so which is not possible, so it's wrong. So it should be same as what is there in the question. Okay, so it should be power 2. Now we need to look for the term to be multiplied with a, b and c. Okay, not on Tuesday, we will see some other day. Then try to be there on Thursday. If not at 8, at least by 9, just for 1 hour. I know it is early, so I'm not sure about other students if they don't have classes on Thursday at any other time, because for me any other time is okay. Which time you prefer on Thursday? Tell me. I will post it in the Kizala group as well as send by mail. So we will schedule the class at that time if all agree. At 10 o'clock. Okay. Not a problem. I'll keep the class starting from 8 until from 10 as well. I'll discuss. Okay. So let me just come back here. Now here, just I'll give you this idea and then you can work with it. Now you need to find the terms which get multiplied with a, b and c. Here the cross multiplication will not work because it is similar to what you have, say 2 over 3, and if you have 5 over 6. Here you will not say the LCM is 3 into 6. Instead you say that it is 6. Why? Because in 6 you can write 3 times 2 and 3 is already here. So that's why you take the LCM as 6 and then you write it as 2 times 2 plus 5. So we have to work on the same idea here. Thursday from 2 to 4. Okay, now I note down these two timings and then I will ask the students which time they prefer. Okay, 10 to 12 or 2 to 4. Or otherwise, if some are okay with morning time, some with afternoon, what I will do, I will keep one class from 10 to 11 and I will repeat it from 2 to 3 on Thursday. Okay, and I will inform you by mail. Not a problem, Abdul Rahman, if you have another class. Okay. What about you, Shada? Fatma? Is it okay 2 o'clock for you? Or do you have any other class? Fatma, Shada, Hilal, Omar, do you have any other class at that time? 2 o'clock on Thursday. Okay, then I will keep it on at 2 also. Fatma, you have class at 2? Okay. Okay, not a problem. What I will do, I will have regular class from 8 to 10. I will see whoever attend there. Then we will take 1 hour class from 10 to 11. And then the repetition of those two classes again from 2 to 3. So whenever you are free, come and join. Okay? Not a problem. Okay? So let me just complete this one and then we will finish with today's class. So when you are looking for the term to be multiplied with a, but you can see below a you have s plus 2. So out of these two terms, s plus 2 already gone. So you left with s minus 3 power 2. So this complete term come here. Okay. Now let's look at c first. Below c you have s minus 3 power 2. So this term already there. So you left with s plus 2. That will come here. Now the thing is with b. With b you have s minus 3 but only one time. So what you can do, s plus 2, s minus 3 power 2. Can you write s minus 3 power 2 as s minus 3? S minus 3 and this term s plus 2. So below b you already have s minus 3. So you cancel this s minus 3. You left with s plus 2, s minus 3. This comes here. Clear? If not, I have another way. Say you have s plus 2 b over s minus 3 and I'm sure you will find this more easy. S minus 3 square. You are okay. Then this total, this all term multiply with the denominator from the question. S plus 2 s minus 3 power 2 all term. Okay. So when you are writing for a, so s plus 2, if you multiply this term here, s plus 2 s minus 3 power 2, s plus 2 cancel, so you left with s minus 3 power 2 plus. Now you are working with b. Again with b you have s plus 2 and s minus 3 power 2. So power 2, power 1 cancel. So with v you left with s plus 2, s minus 3. Then with c, again you are multiplying s plus 2, s minus 3 power 2. This cancel. So with c you left with s plus 2. Okay, so this is another way. So see, you do it in any way, you are ending up with the same answer. Is it clear? Okay, good. And then you have to work with the values of s. Now here you have three constant a, b and c. So you need three different values of s. That again you will get from the denominator. One is s plus 2 equal to 0 gives you s is equal to minus 2. One value is this. Second value s minus 3 equal to 0 gives you s is equal to 3. Now here you don't have the third value. You need third value of s to be different. So in this case you can use any value of S other than 2 and 3. So like I don't like to do more calculations, so I'll go for the easiest value. I will start with 0 if 0 is not already used. If suppose one of the value 0 is already used, I will go for 1. If 1 is also used, I will go for -1. So in this case, as 0 is not used, I will go for this. I will not do the calculation for these two. And then done. After you get the values of A, B and C, substitute it here, you will get your answer. You cannot see the solution because I just overwrite it. Okay. So I want you to complete this on your own. I will share these slides with you, okay, by email, because so that you don't have to write. And I will not put these slides in the Moodle because in Moodle I put different recording with the different slides. Okay, so this is for you, those who attended the class. Okay, any question? Okay then. So I hope you got something from today's session. Now, so whatever we studied today, the worksheet is already there in the Moodle. Worksheet number 3, which is having the questions of inverse Laplace transform and the questions on the partial fraction. Okay, I want you to study them, solve them and send it to me by mail or in Kaizala group. Okay, I can check it for you. So keep practicing. There you will find the question of this type as well in the slides, in the worksheet. So think of working on it. Okay. Okay then, that's all for today's class. See you all in next class. Always welcome. You don't have to say thank you actually. This is my job. I have to do it. Okay. And thanks to you that you are attending the class regularly. Okay then. See you. Take care. Okay. If any doubt is there, you can contact me through Kaizala or by mail. Anyway. Okay. I am available. Then about the class on Thursday, I will have the regular session at 8, then at 10 and then at 2 o'clock. So whichever time you are free, you are available, you can join. Okay. Take care and keep studying.